All right, hello, welcome back. Um, Continuing on with research summaries, we've got practice number 2 and practice and homework number 2 today. Practice and homework number 3 tomorrow, and that'll be it with research summaries. Do 4 days of this, and then we'll move on to conflicting viewpoints after that. So what are we doing today? Word search. Last time, from last week's homework, anthers, nylon bags, total mass, closed lid, aerobic bacteria, all phrases that would have helped you find answers. You didn't have to read a lot. You had to do word searches. So practice today, I will say, can you follow a procedure? We'll look at following procedures. We'll talk about IVs and DVs. We're going to skip your last passage in the practice. So, this one, talking about grass, skip that. Or do you have extra practice? The key that I will put on Schoology has that work on it. That's good. And then research summaries, homework number 2, just a few tips I'd like to mention. Percent error, there's a formula there for percent error, which you may or may not have seen, and the conversion from a meter to a millimeter. Hopefully you know those, but that's about it in terms of new stuff. Last passage is going to have you matching the pictures. So let's jump into some research summary practice. All right, so here we are looking at practice number 2. Once again, get your colors out. I'm gonna try and keep these distinct enough that y'all don't get too confused. Pink, and then that'll work. Okay, so let's get after it. Open this thing up. First passage got you talking about honey, different concentrations of honey, doing some testing on that honey. So let's get into it. Once again, I'm just not going to spend any time reading any of this business. It's just not the best use of your time. I'm going to notice, okay, I got experiment 1, got a data table. Experiment 2, got some samples. Experiment 3, ugh. Experiment 3 looks kind of gross. It doesn't really tell me much of anything. But, I got 3 experiments. So let's jump into it. Number 16. Circle that word suppose. Suppose that in experiment 1, the students had also tested a 70% honey solution. So that's another hypothetical. Well, what if we had done this? Based on the results of experiment 1, the percent change in mass would most likely have been. So we go over here and say, okay, I don't have data for 70%. But I do have percent change in mass data for 60%, and I have it for 80%. What can I assume? Gosh, I'm thinking it's got to be somewhere in there between 45 and 77. That's going to be an answer of H. So hopefully you can see, oh yeah, 70s between 60 and 80. So the answer should go in between the corresponding percent changes in mass. Number 17, when the students added the samples to the bags in experiments 1 through 3, add the samples, they only partially filled the bags. The most likely reason for that is, okay, they only partially filled. So what does that mean? There is extra room in the bags. Why would they leave extra room? Would they leave extra room for things to get in, or would they leave extra room for things to get out? Well, hopefully you can say exiting doesn't make any sense. It's going to be A or C. It doesn't make sense if you need extra room, don't let stuff in. As opposed to, why would you need extra room if you're going to let stuff out? Okay. Take a look back at the test. Partially filled the bag. What's going to enter? H2O or sugar? Go back and search that. When you take a look back, partially filled the bags. Why did they only partially fill the bag? Well, okay. During osmosis, H2O flows across a membrane. Oh, H2O. H2O is the thing that's flowing. All right. From a solution having okay, so it moves from lower into one with higher. So, okay, so into, all right. So it's the water that's flowing. H2O can pass through tiny pores, but larger molecules such as sugars cannot. Okay, great. So it's the water that's moving. So the water has to enter the bag, so that's got to be answer option A. Number 18, we look at that. Experiment 1, to make the 60% honey solution, the students most likely mixed which of the following? Okay, so let's go back to procedure for experiment 1. All right, so for, all right, 2 mils of 100% honey and 8 mils of H2O for the 20% solution. Okay, 2 to 8. So what do you think it's going to be for the 60% solution? All right, so 20% has 2 milliliters. So what's 60% going to have? Well, gosh, hopefully you recognize if it's got 2 milliliters of honey for the 20% solution, it's going to be 6 milliliters of honey for the 60% solution. But how much water are we going to have? Well, here we had 2 and 8 makes 10. Down here, well, 6 and what makes 10? 6 and 4. So 6 mils of honey, 4 mils of H2O. It's got to be answer option H. Okay, 3 down, 3 to go. Number 19 says, according to the results of experiment 1, so we know where we're looking. For the 40% honey solution, did the mass of the solution in the bag increase or decrease as a result of having been submerged, and why? Okay, so let's look back at experiment 1. Looking at the 40% honey solution, thing very clearly increased, went up. So it's got to be increase. We can cross out C and D. Why do things increase? Okay, well, look at the difference. Lower solute concentration or higher solute concentration? All right, well, what is that? During osmosis, we saw this earlier. Things flow from lower solute concentration into one with higher solute concentration. So it flows into higher. So water flows from lower solute to higher solute. That's the H2O that flows there from lower solute to higher solute. So if it went up in mass, it must have gained water. If it gained water, it must have had that higher solute concentration. So that's going to be B. It's trickier. You have to understand like a procedure now. Based on the results of experiments 1 and 2, the concentration of honey in the sample from company Y was most likely. Well, let's look company Y. Here's company Y. Percent change in mass, 85%. Well, 85 fits in there between 77 and 95, so that's between 80 and 100% honey. That's going to be answer option H. And one left, a tricky one. In experiment 3, okay, the mass of one of the bags decreased. Oh, one bag went down. Okay. The bag that, this bag had most likely been the bag submerged in the honey containing. Okay. So if we've got a weird one, we've got an odd one out. Probably happens, look at the extremes. If you've only got one odd one out, I'd look at the extremes. Which one probably went down? Mass of one of the bags. So we put in that bag 20, 40, 60, 80, or 100% honey. Okay. Sample of company Z's product was added to the 5 bags. Okay. For one of those samples, decreased. This is tricky. How do we know which one it's going to be? So what did we do? We placed this in, we put Z into, you know, 20, 40, 60, 80, or 100. And we're saying for one of these, it behaved opposite. So I would look, okay, so the answer is probably one of these extremes. I'll tell you, you can get the answer is 100 without knowing anything. Why? Is 20 an answer option? No. Pick the extremes. If you want to have more explanation about why that one's true, talk to me in class. That's hard to explain. For most of you, it would be enough to say, oh, I'm going to pick the extreme one. One of the extremes isn't an option, so I'll pick the other extreme that is an option. 100% honey. Keep working. Go on to the next one. Next one's talking about, magnetic fields, electric currents, all sorts of fun stuff. Stop, pause, give yourself a little 6-minute timer and try this one on your own. Did you pause? I hope so. So let's try this one together. Again, I got some figures, I got some tables, all very nice. I'm going to just jump into questions. In study 1, as I was increased, the number of electrons that were pushed to one edge of the strip, what did it do? All right, study 1. All right, as I increased, well, what the heck do I know about electrons pushed to the edge? Well, turns out if you search for this, you'll find it. You'll find that electrons are pushed to the edge of the strip, making it negatively charged, and so a voltage develops between those two edges of the strip. Okay, so it has something to do with voltage. And where do I see voltage? I see voltage right here. So as current goes up, as I goes up, it looks like voltage also goes up as well. Increase, increase. That's going to be F, increased only. Number 23, the clamp that fastened to the strip to the ring stand was electrically insulated. This insulation was most likely needed too. What does insulation do? First off, if you didn't know what insulation does, insulation prevents the flow of things. Could be of heat, thermal energy, could be electricity. Insulators prevent flow or slow the flow. So what was the insulation needed to do? It's not there to promote the flow of electrons. And it's not there probably to do with anything about room temperature. Because do we see temperature anywhere else in this? Temperature is never mentioned. So you can probably cross out C and D because who mentions temperature? Nobody ever does. What do insulators do? They prevent the flow of electrons. B. That's a little bit of prior knowledge you need to know. If you didn't know what an insulator was or insulation, it's in your house. It's wrapped around wires. It's the thing that keeps you from, well, losing all your hot air to the outside or getting shocked by the toaster when you plug it in. Number 24, in study 1, which variable was independent and which variable was dependent? Independent is the one we change. Remember, we control the independent variable. The dependent one is the one we measure responses to. In study 1, you look over there. Study 1, your IV is going to be the first column. Your DV is the second column. So independent variable is current. Dependent variable is voltage. Current and voltage. It's going to be answer option G. 3 down, 3 to go. Number 24, it's got to suppose a new trial were conducted using the procedure from trial 1, except that we've got a new B value. Based on the results of study 2, okay, so we got to combine info. VH for this trial would most likely be. So what's going to happen? What happens to VH? when, what happens to B? Okay, except that B is 0.2. Well, initially in trial 1, B was 0.6. So what happens if B goes down? What happens to VH when B goes down? All right, so initially, this was our initial number. This is where B equals 0.6. We got 13 out. Well, what happens if B goes down? If B goes down, voltage also goes down. So when B goes down, V goes down. So what do I expect? It should be less than 13. What am I seeing there? Okay, it says, what if we made B 0.2? Well, it was 0.6, and now we made it 0.2. So what happens when B gets smaller? When B gets smaller, the corresponding voltage gets smaller. 2 left, 26. Based on the information, the letter N in figure 3 identifies N, S, N and S, the poles of an electromagnet. Poles. It's the north pole of a magnet. N for north. H. North pole of an electromagnet. It also uses the word electromagnet right there, right above figure 3. Last one. Based on the results of the study, which of the following equations correctly relates VH to I, B, and D? That is, are they direct, which will mean they're on top, or inverse, which will mean they're on bottom? Quick reminder. So I need to look at the relationship. First, I and V. As I goes up, V goes up. So there is a direct relationship there with V. So V is going to be in the numerator. Sorry. All right. Reverse that. Direct relationship between V and I. So if V is on top, I's also got to be on top. So right away I can cross out options B and option C. Direct with I and V. So that means it's going to be on top. Let's look for B. Let's look at the next one there. As V goes up, B goes up. So that's also direct, another direct relationship between B and V. So that means B is also going to be on top, top, top. Answer is going to be D. So you've got not just to read tables now. We're still reading tables. There's still going to be easy table reading questions. But you've got to go back and look at the procedure, and more often than not, a little bit of a word search. If you looked for the letter N, and you found the letter N, and you looked around a little bit, and you saw poles of an electromagnet right above it, that might have helped you. So looking around for those words, use your answer options to help you zoom in on things. You've got a question about grass. If you are one of those people trying to get even more practice in, if you're trying to get above 28, I would try and do that last practice problem. Not too worried about it for the rest of you. Group work 2, taking a look at this guy, your assignment for the day. You've got questions about some chemistry stuff, ozone and iodide ions. You got some questions about diffraction. And you've got some questions about some biochemistry. So you've got chemistry, physics, and biochemistry all in one. You need to do all 3 of these. Make sure you're getting those things submitted. Special things to look out again for on the first one. Do you know what the formula is for percent error? I gave it in the beginning of the lecture. Number 2, man, do you know how many meters or in millimeters? Excuse me. Do you know how many millimeters are in a meter? Yeah, that'd be good. And the third one, you're going to match some pictures. Just picture matching. Turn the light switches on and off. Okay. So there's number 2, research summary number 2 stuff. We are done. Next thing you'll see is research summary number 3.